Hello everyone. Before we dive into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription truly makes a difference and helps this channel grow. If you enjoy our content and don't want to miss our upcoming videos, subscribe to the channel and turn on the notification bell to receive all updates. And what if I told you that, right now, a solitary traveler is crossing our solar system, coming from another corner of the galaxy? A celestial body that has traveled for millions, perhaps billions of years, carrying with it the stardust of distant suns, the cosmic silence of unexplored regions, and perhaps fragments of a story that predates the birth of our own sun. Its name is 3I, Atlas, and it is the third interstellar object ever identified in our region of space. Not just any comet, not a common asteroid, but a true galactic messenger, whose origin remains shrouded in mystery. The discovery occurred in June 2025, when the Atlas telescope in Chile detected a bright point moving at an unusual speed. Astronomers immediately noticed something strange. 3I, Atlas is traveling at about 60 kilometers per second, a speed unsustainable for an object gravitationally bound to the Sun. In other words, this body was not born in our solar system. It does not orbit our star but passes through it, like an alien traveler crossing the path of an unfamiliar world. The prefix, 3I, stands for Third Interstellar Object, after Oumuamua in 2017 and comet Borisov in 2019, while the suffix, C, 2025 N1, indicates its classification as a comet discovered in the first half of July 2025. Spectroscopic observations reveal that 3I, Atlas possesses a faint coma and a barely developed tail, signs of cometary activity. But its composition remains unknown. We do not know if it contains the same elements as comets from our system, nor what minerals or molecules it is made of. It's as if a bottle with an encrypted message had just been thrown into the ocean of our astronomical understanding. The importance of 3I, Atlas goes far beyond mere interest in an exotic object. This body represents a unique opportunity to study the raw material of other stellar systems, matter that has not undergone the evolutionary processes typical of our planetary environment. It is a pure, untainted sample that allows us to compare the processes of planetary system formation in different galactic environments. We might discover that comets from other systems are similar to ours, or radically different. And from this comparison, an even deeper truth may emerge. Perhaps the fundamental building blocks of life, complex organic molecules, are not exclusive to Earth or our solar system. The trajectory of 3I, Atlas is hyperbolic, a clear sign of its interstellar nature. It is expected to reach its closest approach to the Sun, perihelion, toward the end of October 2025. During that period, it might become visible even to amateur telescopes, offering millions of enthusiasts around the world the chance to observe a fragment from another star. But space agencies are looking beyond mere optical observation. Some NASA and ESA scientists are already considering the remote possibility of launching an interception probe, perhaps using experimental technologies like solar sails or ion thrusters, to reach it before it leaves our system. A colossal endeavor, at the limits of our current engineering capabilities, but one that could open the door to interstellar science. To fully grasp the significance of this event, just remember that before 2017, we had never observed an interstellar object. The very idea that rocks from other systems could pass through ours was considered unlikely. But since then, in less than a decade, we've discovered 3. This suggests that such visitors are far more common than previously thought. Perhaps our system is constantly crossed by objects from other worlds, too small or too dark to be noticed. And what if there exists a galactic stream of interstellar debris, a sort of river of cosmic ruins traveling between stars, carrying forgotten stories and, potentially, ingredients of life? The possibility that 3I, Atlas contains complex organic molecules is far from remote. Comet Borisov already showed traces of cyanogen and carbon, key elements for prebiotic chemistry. If Atlas reveals a similar composition, we might be facing confirmation that the building blocks of life are common throughout the universe. And this would inevitably reopen one of humanity's oldest and deepest questions. Are we truly alone? But there's another, more unsettling aspect to these objects. They travel alone. They are not part of a swarm, they are not followed by similar bodies. They are wanderers, like exiles expelled from their parent systems due to catastrophic events, planetary collisions, stellar explosions, or extreme gravitational perturbations. Every interstellar object could tell the story of a destroyed world, a chaotic system, or a broken balance. Atlas could be a fragment of a vaporized planet, a piece of a shattered moon, or an ancient comet that survived a stellar explosion. And as scientists observe its movements and try to unlock its secrets, a silent question creeps into the minds of the curious. If we can observe them, is it possible that we are also being observed? In the silent heart of the night, as 3I, Atlas glides through cosmic darkness, its presence subtly but profoundly interrogates us. Not only about its origins but about our own. If these objects freely wander the galaxy, carrying traces of remote worlds, then our own solar system may have received similar visitors in distant epochs. And what if, millions of years ago, an interstellar comet struck primordial Earth, introducing chemical elements not present in our protoplanetary disk? What if the seeds of life were sown by one of these wandering messengers from an unknown point in the Milky Way? This isn't science fiction but a real possibility explored in scientific scenarios under the name of interstellar panspermia. According to this theory, some elementary forms of life, or more likely, molecular precursors of life, could travel embedded in the ice of comets and asteroids, surviving for millions of years in the vacuum of space, until they find favorable conditions on a host planet. If 3I, Atlas truly contains such compounds, each of its particles would represent a bridge between two worlds, a possible invisible thread linking civilizations separated by light years and eons of time. And yet, its visit will be fleeting. After skimming the sun, it will accelerate again, pushed by our star's gravity, and continue its journey into the unknown. Perhaps it will pass by another stellar system in hundreds of thousands of years. Perhaps it will be captured by another gravity or shattered in a collision. Or perhaps it will wander forever, silent, as a mute witness to a galaxy in perpetual motion. Its path will never return. There will be no second visit. That's why every moment counts. In NASA's laboratories, digital models are being refined to predict the best observation points. The most advanced spectrometers have been aimed at it, trying to decipher its chemical signature, and yet its brightness remains faint, elusive, as if it wants to conceal its secrets. Some data suggest it might contain water ice, but also traces of complex nitrogen compounds, perhaps derived from environments similar to those that gave rise to amino acids on Earth. But definitive confirmation will be difficult without a direct probe, a field analysis. And it is here that science fiction begins to brush against science. Ultra-fast mission projects, like those inspired by the breakthrough starshot concept, are being dusted off from theoretical lab folders. Using light sails, accelerated by ground-based lasers, to reach objects like 3I, Atlas before they flee beyond Pluto. It's not easy. Time is extremely tight, and the technologies are still experimental. But the idea has already ignited scientific debate. Because there won't always be a next time. Every interstellar visitor is unique. We don't know when, or if, another will come. The encounter with 3I, Atlas is not just an astronomical event. It is a confrontation with the unknown, a chance to expand the boundaries of our knowledge and imagination. It represents what makes astronomy great. The ability to look beyond the horizon, to question the sky and find unexpected, sometimes unsettling, answers. Atlas reminds us that our place in the universe is neither static nor isolated. We live in a galaxy that is alive, dynamic, where objects move, collide, disperse, travel, and sometimes, rarely, cross our path. We don't know if 3I, Atlas is the child of a star similar to our Sun or if it comes from a chaotic region, like the outskirts of a binary system. We don't know if it was expelled by an explosion or if it left its home silently, dragged away by a destabilized orbit. But we know it is here, now, and its story could enrich our understanding not only of the cosmos but of the origins of life itself. There's something almost poetic about all of this. A foreign, uninvited object intrudes into our system, bringing with it inaccessible secrets, perhaps an echo from a time when the universe was younger and more violent. And we, small creatures on a small planet, try with all our might to decipher the message, to listen to that distant voice that, perhaps, tells us something about ourselves. When 3I, Atlas has disappeared from our sky, it will leave behind a deep scientific and philosophical legacy. Because every time the universe grants us a fragment of its immensity, it compels us to look not only upward but inward. To ask ourselves who we are, where we come from, and whether, somewhere out there, someone else is watching a tiny comet from our corner of the galaxy, wondering the same thing.